Hi guys, today we are beginning our lesson on this packet. It says Unit 3, Part 2. Now we're going to begin graphing polynomials and finding all of the zeros and tying it all together with the graphs. So today I just want to talk about the properties of graphs. I'm on page 1 of the packet. All right. First, we've been doing polynomials and we've gone over this stuff before, but let's just reiterate a couple of these things. All right. The definition of a polynomial function is a monomial, one term, or a bunch of single terms added together or subtracted that have real number coefficients. Means there can't be i's in the equation, there can't be square roots in the equation, and your exponents all have to be whole numbers. So your exponents are all 0, 1, 2, 3, and so forth. They're not allowed to have negative exponents. You can't have fractions. You can't have square roots as the exponents. All right. Your standard form we've been doing where it counts down, the exponents count down. So if x to the 4 is the highest exponent, it's going to be x to the 4, x to the 3, x to the 2, x to the 1, the constant, just the number. If x to the 3 is the highest, it'll go 3, 2, 1, and then the constant. We know that the degree, we've been talking about this a lot, is your highest exponent, and your leading coefficient is the number in front of the variable with the highest exponent. So first we want to just talk about identifying polynomial functions. We want to ask, is it a polynomial or not? So the questions you need to ask yourself is what we just went over up here. Okay, are all the coefficients real? That means we can't have imaginary and we can't have square roots as our coefficients. And are all the exponents whole numbers, which means we can't have fractions, decimals, or negatives. Once we determine that's a once, the hole punch took it out. Once we determine that the function is a polynomial, then we can classify it by its degree and its number of terms. Its degree is the highest exponent. All right, so if it's first degree, if x to the 1 is the highest exponent, it's linear. If x to the 2 is the highest exponent, it's quadratic. X to the 3 is called a cubic, I apologize. Fourth and up, we're just going to call it the 4th degree, the 5th degree, the 6th degree, and so forth. Your number of terms tells us if there's only one term, it's called a monomial. Two terms, so like monomial would be 2x. A binomial would be 2x plus 1. A trinomial would be x cubed plus 2x plus 1. All right, one term, two terms, three terms. All right, so let's do a couple of these guys. All right, we want to first decide if it's a polynomial or not. If it's a polynomial, you're going to write it in standard form, classify it by its degree, and determine its leading coefficient. If it's not a polynomial, we just want you to explain why. So this first guy, is this a polynomial? Are all the coefficients real? Real number, real number, real number? Yes. Are all the exponents whole numbers? No fractions, decimals, negatives? Yes, yes. So yes, this is a polynomial. Now we need to write it in standard form. Standard form means our exponents count down. So we would have 7x cubed plus 2x squared minus 1 is our standard form. All right, now we want to classify it. When we classify this, the highest degree is 3, which means it's cubic. And we have 1, 2, 3 terms. So the number of terms, 3 terms, is called a trinomial. All right, and then the leading coefficient is the coefficient on the highest exponent, which is 7. Remember, you have to put it in standard form before you can do that. So it's a 7. All right. Number 2, is this a polynomial? Are all the coefficients real? Real, real, real. Good. Are all of the exponents whole numbers? No, because this has a negative exponent. So this is not a polynomial, because we have x to the negative 2. All right. Number 3, is this a polynomial? Okay. Do you have all real number coefficients? Okay. So if you have real number coefficients, you're going to have real number. This is a real number, so we're okay there. Okay, and then do we have whole number exponents? Yes, yes, yes. So yes, this is a polynomial. Now we need to rewrite it in standard form. So we're going to have the f of x equals, we're going to have the highest exponent is negative 4x squared plus pi times x plus the square root of 5. All right, we're going to classify it. The highest exponent is x to the 2, which means it's squared. All right, so if it's x squared, that means it's a quadratic. Get it right here. If the degree is 2, it's called a quadratic. It's a quadratic, and there are 1, 2, 3 terms, so it's a trinomial. Okay, our leading coefficient is negative 4. Alrighty, guys, are you following this along? So if we look at number 6, is this a polynomial? Yes, it passes the real coefficients and the whole exponents. So then we need to put this in standard form. We're going to get negative x plus 2. What's the highest exponent here? What's the degree? This is really x to the 1 power. If it's x to the 1, that means it's linear. Okay, x to the 1 means linear. If we graph this, it's a line. And then if there's only 2 terms, it's called a binomial. It's leading coefficient. All right, I wrote lead here, I wrote LC, leading coefficient here, it doesn't matter. All right, is negative 1. Okay, notice this one, the degree is 5. It's already in standard form. It's a, yes, this is a polynomial, and it's already in standard form. Okay, so to save some time, we're going to move on to the next page because we got a lot to talk about with graphing. All right, when we graph a polynomial, one of the first things we want to do is we want to look at, and this is going to look like a lot of writing, so just hang tight as I'm going through. Okay, the first thing you want to do, remember guys, you need to take good notes. Take good notes today. All right, first thing you want to do is you want to look at the degree of the function. If the degree is even, that means you're going to have x squared or x to the 4 or x to the 6 and so on. If the highest exponent isn't even, then the ends of your graph are going to point in the same direction. All right, it'll be like this or like this or same direction here. They're pointing in the same direction. If your degree is odd, that would mean x to the 1, x to the 3, x to the 5, and so forth. Then they point in opposite directions. Here, they're pointing in opposite directions. Here, they're pointing in opposite directions. Here, opposite directions. One up, one down. One up, one down. One up, one down. Even, both up, both up, both down. All right. Your leading coefficient tells you which way. If your leading coefficient is a positive, it's opening up, or it's finishing up. This finishes up. If your leading coefficient is negative, it points down, just like when we did parabolas. So it points down. This would be a negative leading coefficient. This guy would be a negative leading coefficient because it ends down. It begins on the left and it ends on the right. Begins on the left and it ends on the right, just like we read a book. So if your degree is even, then your leading coefficient is positive, your ends are going to look like this. They're both going to be up, or it's going to wiggle and both point up. Okay, we use this notation. We say as it goes, right, as your x goes to the right, then the left is going to be this is a mistake, okay? This should be as x is negative infinity, then y is positive infinity, okay? As your x goes to the left, your y goes up. So your x, this arrow means goes to. So as your x goes to the left, you want to write a left here, your y goes up. And as x goes to positive infinity, which is the right, your y also goes up. Okay, so as your x goes to the left, your y goes up here. And as your x goes to the right, your y goes up here. I'll show you this notation as we work through the next couple problems. If your leading coefficient is negative, then it points down. Okay, so as x goes to negative infinity, which means as x goes left, your y goes down. And as x goes, this should be positive infinity, your y goes down. This should be negative infinity. So as x goes to the right, y, your f of x is your y goes to negative infinity, it goes down. So on your left, x goes down, or your y goes down, and on the right, y goes down. So as x goes to the left, y is going down, and as x goes to the right, y is going down. Okie dokies. If it's odd, then we're going to look at this. So if you have a positive coefficient, that means it's going to point up. It could wiggle and go up. It could wiggle a couple times and go up. But they're all going to point up. All right? So this is saying as x goes to the left, y goes down. See that? As x is to the left, y is going down. And as x goes to positive infinity, which means up, to the right, then y goes up. As x goes to the right, y goes up. As x goes to the right, y goes up. As x goes to the right, y goes up. All right. Now, if we have a negative leading coefficient, that means it's going to point down. It could be here and point down. It could have lots of bumps and point down. But if your leading coefficient is negative and you have an odd degree, then that means it's going to point down. So as x goes to the right, then your y goes down. And as x goes to negative infinity, which means the left, your y goes up. As you go to the left, it's going up, and as you go to the right, it's going down. Okay? We've also talked a lot about how to determine the maximum number of zeros or roots, okay? If you look at your highest exponent, okay, your degree tells you how many solutions. If you have a degree of 3, we just worked on all this with our polynomials, right? If you have x cubed as your highest exponent, you have 3 answers when you solve it. If you have x squared as your highest exponent, you only have 2 answers. If you have x to the 7 as your highest exponent, you're going to have 7 answers. So let's talk about a couple of these, and then we will work on the rest together in class. Okay, and I want you to just cross this off right here in the directions. We are not going to do this part, state the domain and range. So first things first, we want to look at this and we want to say, is this even or odd? Okay, it's x to the 5, which means it's odd degree, okay, and it's a negative exponent. So it's an odd and it's negative, which means what? If it's odd and it's negative, then we're going to come back here and we're going to say, look, it's not even, it's odd, and it's negative, okay? Which means our ends are going to look like this. So hopefully you took gorgeous notes. If you want to break them up with lines, you can, okay? To like chunk this together. If it's an odd negative, that means that it could be something like this, where it's up on the left and it drops. Okay, so to the right it drops. So now we need to write it in our notation. Okay, as x goes to the left, negative infinity. What happens? As x goes to the left, our y goes up. So we're going to say our f of x goes up, which means positive infinity. And then we also need to do as x goes to the right, positive infinity. As x goes to the right, what happens to our y? It goes down. Going down means negative infinity. And how many solutions do we have? If you have x to the 5, that means there could be 5 solutions. That's what it's asking for. We want to write down the end behavior, draw a little sketch, and come up with how many solutions. So, number 2. First we need to decide, is it even or odd, and is it positive or negative? The highest exponent is 4, okay? So it's even, and it's a positive 1 as the leading coefficient. So it's even and positive, which means what? If you come back here, even, positive, means it's going to both point up. They're both going to point up. Okay, so you've got this as an answer. Or you could say, hey, I might have a bump, right? Each bump can be like an answer. We'll talk about this a lot more as we graph more. Now, as we write our answer for our end behavior, it's always as x goes to negative infinity and as x goes to positive infinity, right? As x goes to negative infinity is the left, positive infinity is the right. So as x goes to the left, what happens to y? Y goes up. So that means that f of x is going to go up. Up is positive infinity. For x, positive infinity means to the right. As x goes to the right, what happens to our y? Our y goes, as x goes to the right, y goes up. So it also goes to positive infinity. Okay, how many solutions can we have? Our highest exponent is 4, which means we could have 4 solutions. Okay, so let's do number 3. Okay, first thing we need to do is we need to look for its degree. Be careful, is this in standard form right now? This is not. So if we put it in standard form where the exponents count down, we're going to have negative 2x cubed plus x squared minus x plus 2. What's the degree of this? Right here. Okay, that's our leading term. We have odd, and it's negative. So if we have odd and negative, that means what? Okay, our graph is gonna go down. Okay, it drops down. You could handle how many solutions right now. If it's x to the 3, that means we're going to have 3 solutions as the top number of solutions. So now let's do our end behavior. As x approaches negative infinity, what happens to y? And as x approaches positive infinity, what happens to y? All right, you always write both of them. As x goes to the left, what's happening to our y? Our y is going up. So how do we write up for the y? It approaches positive infinity. Down here, as x approaches the right, what happens to our y? Our y goes down. How do we write down? Down is negative infinity. That's your end behavior. So I'd like you guys to try number 4 on your own. Put it in standard form first, pause the video, and then come back, all right, and let's go over this. If we put this in standard form, we're going to get 3x cubed minus 7x squared minus 4x minus 9. So this is our leading term, which means it's x to the 3 odd and positive. So odd and positive means what's it going to look like? I'm just going to draw some lines here so I have space. All right, odd and positive means my graph is going to go ends pointing in different directions, but it's positive, so it's going to finish pointing up. Okay, so it's going to point up. And when we look at this, we have x to the 3, which means we have a total of 3 solutions. Alrighty, so now we need to write down our end behavior. So I hope you guys did this. As x goes to negative infinity, what happens to f? And as x goes to positive infinity, what happens to our y, our f of x? So as x goes to the left, what happens to the y? It goes down. Down we write as, so our y goes down, negative infinity. As x goes to the right, what happens to our y? Our y goes up. So if our y goes up, that means positive infinity. Okay, so if you want, try these on your own. We're going to go over these next class. We're going to do these. We're going to talk about these, and of course, we're going to practice more. Good job today taking beautiful, thorough notes.